one module, that is Wireshark. And from today, we are going to start a new module, which is known as a Cisco Packet Tracer. So what we can do, Cisco Packet Tracer is a simulator where we have a lot of capability to do what we want to do with the network devices, some network devices, enter devices, all the uh, physical devices which we see on in our real life are available in Cisco Packet Tracer. And before making the connection, suppose we are in an organization and we are supposed to set up a network for the organization. Then we want to check that how many devices are required, how to configure the host, how to connect one building to another building. Uh, these all the idea can be implemented using Cisco Packet Tracer. So first of all, you are required to install Cisco Packet Tracer on your machine. It is available for Windows. You can download it from Cisco Networking Academy. You have to create your login and you can go there. Here, download Packet Tracer is available here. So Windows version, and it is available for Windows, Linux, and Mac OS. So you need to install on your machine, and we can start Cisco Packet Tracer using a Packet Tracer command on Linux. So currently Packet Tracer 8.1.1 is available. So uh, I will tell you, in previous release of Cisco Packet Tracer, what was there that uh, we were not able to configure the IoT devices, but in the latest version of Cisco Packet Tracer, we are able to configure the IoT devices also. Like a lot of some improvement, the latest version of Cisco Packet Tracer released, and I have latest version 8.1.1 installed on my machine. So what we can see here, IoT devices are also available. So we can drag and drop the IoT devices also and make the connection and test it using latest version of Cisco Packet Tracer. Uh, Now I will tell you how to work with Cisco Packet Tracer. These are all the well-known menus. We are all familiar about this. So this is the white space. This is known as a work area. And see here, you can see the time is running. There are some menus are there. If you click here, you can see the network devices. Again, you click here, you will see end devices. In end devices, there are some options like uh, PC, laptop, servers, name server, network controller. Again, some components are there. Some wires are needed to connecting the network devices. So these all the features are available here. What we can do, we can just drag and drop and do the implementation. How we can connect one computer to another computer using switch and hub. In today's lab, we are going to just uh, learn the concept of Cisco packet trace, and we are not going to do any extra thing. So we will be demonstrating switch and hub. To know about switch and hub, we must know that how to configure a device, how many types of wire. Actually, if you're physically available in our MLNIT, then we have a separate lab for LAN cabling, where we teach you that how to create a cable using plier, using cable, using RJ45 connector. We give the assignment to create a cable, so you will become familiar about the uh, types of cable and why it is used. Generally, crossover cable and straight through cable we use for making connection. So in general words, if I will say, if we want to connect similar type of devices, then we use crossover cable. You can see here. See, this is crossover cable, a cable with small gap between. You can see the details description of the entity which you selected on Cisco packet tracer will be shown here. This is straight through cable. Straight through cable is used to connect the different layer devices. And if I were talking about the similar devices in case of router to router connection, there is some another technology we use, serial connection. So when we will use the router to router communication, we will see how to make the connection. But generally we do serial communication. So, but we can generally say that for similar type of devices, we use crossover cable. And for different type of devices, like if you are going to connect hub through a PC, then we are going to connect using straight through cable. Uh, One more thing, whenever we are going to do connection, create a connection. Suppose let me show you some demo, right? So first, I am going to show you how to connect the difference between the hub and switch. So I'm selecting a network devices, and from here I'm selecting hub. And what we can see, some PT hub is there, PT repeater is there, coaxial splitter is there. So I have selected PT hub switch, sorry, not switch, PT hub, just drag and drop. If I will click here, it will show me that how many fast Ethernet port are there. So how many fast Ethernet port means how many RJ45 connector can be connected with this hub. If these 5 interface are not sufficient for us, then what we can do? There is an option to add some functionality to the hub. So the same functionality is available for hub, router, and switch also. So suppose we want 6 Ethernet port, 7 Ethernet port, and we have only 5 inbuilt there. So there are blank spaces in your switch. If I can zoom it out. See, these are some interfaces, link, 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 like, and some blank spaces are there. Blank spaces can be utilized to adding the functionality to the hub. So to add the functionality, what we need to do, we need to switch off it. There are a physical switch, like a switch in hub. The same physical interface is available here. So we need to switch off it. See, the green signal goes off. This is meaning that hub is in off. There is no power supply in hub. So what we can see, these are the list of modules which can be added to the blank spaces. And the description of the description is available here, that what is working of this module available here. This PT repeater NM feature is single Ethernet LAN backbone, which can also support either 6 PRI connection. So this interface, fast Ethernet, gigabit Ethernet, again fast Ethernet, I think. So if required, then we can add. If not required, then we are not supposed to add the modules to the hub. So, but physically in real life, it generally happens as we sometimes we got the blank. Uh, we got the hub or switches with blank spot, and we configure it as per our requirement. So what I have done, I have taken a hub which is having 5 Ethernet ports. So I'm taking some end devices like laptops and PC, and I will make connection among them using hub. So I'm taking some PC. See, I've taken 4 PC. And one thing I will tell you that in modern devices, we are not required to consider that which cable we are using, because the network interface card is capable to convert the functionality that if we are using crossover cable, then it also works, because network NIC has the functionality that it can perform with the wrong cable. Wrong cable also the functionality in internally it can manage. This is the functionality of network modern interface card. But in general, we suppose that we are using crossover cable for similar devices and straight through cable for different type of devices. Suppose I'm going to connect one hub to another hub, then we will be using crossover cable. And for making connection between the PC and hub, we will be using straight through cable. So this is a symbol of cable selection. Once I will choose on it, list of cables are there. And this is the functionality that if you are using this icon in Cisco Packet Tracer will automatically choose the right wire for the making the connection. But uh, as a beginner to bec- uh, do practice, what we will do, we will use straight through cable. Once I will click here, the description of the cable is available. This is a copper straight through cable. We can see here. I will click here, and then we can see generally one fast Ethernet port is available in PC. So I will choose this fast Ethernet port and this. To which fast Ethernet? There are six fast Ethernet port available in hub. So to which we are going to connect PC 0. So I'm selecting fast Ethernet 0. For that we need to do one thing. I'm going to. These are the these are the list of protocols which we can see how these protocols are running between the communication. So I'm going to disable right now for disable all the protocols right now. Then I have made the connection. I'm again going to take the straight through cable. This fast Ethernet 0 port of this PC is connected with C. Fast Ethernet 0 is already connected with PC 0, so that is disappear. Now this. See, um, if you can see that these symbols are red, meaning there is some problem. And what is the problem? When I was going to, I was checking the physical interface of the hub, then I switch off the hub. So we need to switch it on. Once I will switch it on, once the signals, the triangles which you can see that are green, means the connection is established and we are ready for communication. Any one of you can tell me, can we ping from one machine to another machine now? Avigyan,
Yes, sir.
can we uh, send a packet from one PC to another PC right now? Suppose what is the property of hub? If you have the property, if you are sending any packet to the hub, then it will broadcast the packet except the link from which the packet is coming. So if I want to send a packet from PC 0 to PC 2, can we do it, or any other information is required to enable the communication? अभिज्ञान,
Yes.
क्या कुछ समझ में नहीं आ रहा क्या पूछ रहा हूँ मैं? एनीवन, कोई बताएगा? अगर किसी स्पीसीज से कम्युनिकेट करना हो यूजिंग अ हब, then what are the things are required? Only cabling is enough to do the operation, or any extra thing is required?
Sir, I guess we need to set the address of all the PCs.
Yes, without setting the address, we cannot transfer anything. So for that, we need to set the IP address. Like if you are in, we are in a hub using hub, meaning we are using. I think sir have told you the IP addressing. Yes, sir has told you the packet transfer within the subnet and across the subnet. I think this topic should be covered. So to enable to transferring the packet, we need to configure the IP address. And to configure the IP address, we need to just click on this PC. See, this is the physical interface of the PC. This is the CPU, floppy card. This is a power button, CD writer button. So this is the physical view. This is the config view, and this is the desktop. Desktop view, a normal PC, all the terminology which are available in our PC, that is virtually available here. So we can do setup IP configuration, dial-up connection, terminal, command prompt, browser, everything is available for this PC0. So what I'm going to do, I'm going to configure the IP for static IP configuration for this PC, and I'm choosing an address 192.168.1.2. I'm taking two just because maybe sir has told you that whenever we are writing IP addresses, then first valid IP address is always given to the gateway, and the gateway is required when we are going to communicate across the subnet. So we should keep a practice that we are starting the network from second valid IP address. So suppose I'm taking the class C address and 192.168.1.2 as a IP address. The first valid IP address is given to the gateway. So gateway will be 192.168.1.1. So I'm not considering that. And here I'm not entering the default gateway because I'm using a hub and we are doing communication within the subnet. So that's all. I will repeat the process for the PC1 also. Go to the desktop, IP configuration, 192.168.1.3. Again, subnet marks will be entered automatically. Go to PC2, desktop, 192.168.1.4. 192.168.1.5 for PC4. Um, what I have done that I have assigned the IP address, I have made the connection with the hub, and uh, now we should able to ping from one PC to another PC. So to check, there are two modes of how the packet are being transferred. There are two modes. One is real-time mode. One is simulation mode. So in simulation mode, what we can see how the packet is actually transferred from source to destination. So in real time, we cannot see that how packet are being transferred. So we'll do everything in simulation mode. And this event list is a panel where we can see the track of our packet, the list of devices through which our packet is transferring. So what I have done here, I will apply on edit filters, and for that, uh, from now I'm going to enable two protocols, that is ARP packet and ICMP packet, because ARP packet is required to get the physical address of the destination, and ICMP is required to ping from transferring message from one PC to another PC. So I'm not if we it will be very hectic to understand if we will enable everything during the communication, because a lot of things in background also happens when we are going to connect from one PC to another PC. So I'm enabling two protocols. First one is ARP, second one is ICMP. I'll just minimize the window. See what you can see: event list filter, visible events. These two protocols are enabled here. I'm going to delete something is happening. So ARP and ICMP is enabled for this simulation, and there are some messages. Some options are here. You can see that you can add a text, you can delete something, you can insert something. So there is a PDU, protocol data unit, program data unit. So meaning that you can select this message as a source and destination from where you want to send, from to which you want to send, and then you can see how the data is transferring. So suppose I'm selecting this PDU, I'm selecting program PC0 as a source and PC2 as a destination. Then what you can see, there are two messages you can see, because I have enabled ARP and ICMP. So once you will roll over your mouse over this, you can see one is one envelope, that is ARP, not envelope. That's a message, that is ARP, and another one is ICMP. In your event list, there is color coding also. So the dark green is showing the ARP, ICMP, and the light green is showing ARP. It changed all the time. Maybe next time we are doing communication from PC0 to PC1, the color coding may change. So this is just for identification, that you can see that how the package is being transferred. So what will happen once you are going to transfer a packet from PC1 to PC3? Initially, we don't know. Actually, Hub has a property to broadcast everything. So initially, we need to run the ARP request. We know that uh, ARP request is broadcasted. So if I will click here, we can see the protocol stack of the ARP packet. This is fast Ethernet port. Here, Ethernet header, that is source MAC address of the source. Then what you can see in destination MAC, there are all F means that is broadcast address, and the source IP address is, that is 192.168.1.2. This is the IP address to which that will be assigned to our PC0, and our destination is 192.168.1.4. That is our destination address, and we are looking for MAC address of the PC, which is having the IP address as 192.168.1.4. So PC0 will broadcast ARP request to all the nodes, and the node will reply that will having the IP address as 192.168.1.4. You know the concept of ARP, that we just send a message that what is the IP address of what is the MAC address of this IP. So the ARP reply will be unicasted to the requester only, because we know the MAC address of the from where we have the request is generated. So we can see once I will click here, I can play. See, the ARP request is coming. It is coming to the hub. Hub will broadcast this ARP request to each and every node except from which it's coming. PC2 is destined for this ARP. This is IP meshed with PC2. PC2 will send a reply to the hub that yes, this is the MAC address. But hub will what will hub will do? Hub will broadcast this packet also. So others will just discard it, and PC0 will get the MAC address. Now ICMP will come to the hub. Again, we still know the MAC address, but hub will broadcast the packet to each and everyone. Now, message received to PC2. PC2 will send a reply that yes, I have received acknowledgement to the PC0. Again, acknowledgement coming to the PC hub, and hub will broadcast it. So this is the way that how hub is working. So hub generates the unnecessary traffic within the network. So uh, just that's why we generally do not use it. So what we can see the timeline for this. This is the ICMP header. In the simulation parallel in the event list, if you will click here, like at PC0, some ICMP messages are there, and one ARP is there. Uh, you can see the situation. 1 second. Yeah. At PC0, at device PC0, first there is ARP and ICMP messages are there. And then what's happening? First ARP request come to the hub 0, and then hub 0 transfer this message to PC1, 2, and 3, except PC0. And then see. So this is the activity window, how the packet is being transferred. So now what we can do, we can just, the switch has having the property that have is not an intelligent device. I think sir has told you in introduction of devices that uh, have it is just multi-port repeater. Like it does not make decision, right? So to remove the unnecessary traffic within the network, we use layer 2 device that is known as switch. So switch is having the MAC address table. Then decision is taken. Switch is a store and forward device. We can say store and forward devices are those devices which can make decision based on the packet. So what are the information available over the packet header? They can make decision over that. So that is the store and forward devices switch. And so now we have another exercise to do the same thing with the switch. You will do that, right? I'm going to connect with in your assignment we have a question that you need to connect two switches. For that we need some extra thing to do. So for that I'm, and what you can do, whatever the work you have done, you can just click on file and save as .pkt format. You can save your work using .pkt format. And to remove any kind of difficulty, just create a login on Net Academy. After that, whenever you launch Cisco Packet Tracer, it will ask for login to the Net Academy. After login to the Net Academy, you will able to save your work. Else, it will not allow to save your work after 3, 4, or 5 saves. So, create your login on the Net Academy. Yeah. So, I'm going to we can there are some functionality in this. You can delete from here, you can remove the links. So these all can be done. I'm going to, no, I don't want to save my work. So again I'm going to do from here I can use some networking devices. I can go to the switch and I can take a PT switch. Once I will click on this, uh, see, same interface is available. Some blank spaces are there. See, some blank spaces are there. If required, then we can switch off the switch. We can power off the switch, and we can add some interfaces to the switch, and then we can again switch on it. Then we can use the added modules. These are list of modules that can be added to the these blank spaces. So now I'm going to tell you that how to connect with the switch. Switch having the property that it is having the MAC address table. Once I will click on this switch, then what you can see, there are 5 fast Ethernet port are there. Again, these are in one VLAN. VLAN concept is, we have another assignment for VLAN in Cisco Packet Tracer. You will see that how the ports are configured in under one VLAN and how to do the communication among the VLAN. By default, uh, in general, what we can see, all the interfaces of one switch is considered as one under one VLAN in general. If we are not going to create another additional VLAN, we are not going to configure that which port is working under which VLAN. So uh, there is a switch, and in Android devices, I'm going to take some PCs. And before doing anything, do one thing, just select no protocol, right? If you will select everything, you will maybe some steps maybe disappear. So try to deselect everything. Now I'm going to make connection. I'm taking straight through cable to connect PC. There is one fast Ethernet port available in my PC. I'm going to make the connection. See, there's some links are still pink. So what we are going to do, we need to wait for some time. It will become green. I will go to desktop. I'm going to configure the IP of same subnet 192.168.1.2. You can take any IP address, but just be careful that while assigning one address to one PC, uh, you are assigning another address to the other PC that should also be the same subnet. Whenever same subnet, the network ID must be same. So I think you must be knowing that how to get the network address when we do the bitwise AND operator with IPv4 and its subnet mask, we can get the network address. So again, we are in the considering that we are in same subnet, so I'm not going to enter the default gateway. Two, I'm coming to the PC2 desktop 192.168.1.3. Need to configure 192.168.1.4. So we have done the IP assignment of the PC, and we have configured the switch. Then I will enable a few protocols. I will choose that ARP and ICMP. We'll see, can see what's happening. I have enabled it, and I'm choosing a protocol data unit. Ah, see, actually, I will show you that how switch maintains its MAC table. So we have not done any communication till now. I will go to the CLI mode of the switch, and I will try to check that how many MAC addresses are available within the MAC address table of the switch. So for that, there is an command show MAC hyphen address minus table. So what we can see generally, maybe sometimes see the fast Ethernet FA 2x1 is connected with this MAC interface. We have connected 4 PC, but and two MAC addresses are currently stored in our MAC address table, FA 2x1 and FA3x1 interface are generally connected with these MAC addresses. So if MAC addresses are available in the switch MAC table, then whenever we are going to transfer a packet from source to destination, then it will be transferred. So see how it's happening. We can see two packets at PC0. One is ICMP and one is ARP. So ARP is running at come to the switch 1, and switch will broadcast ARP packet to PC1 and PC2. See what's happening. PC2 is sending a reply to the ARP, but switch now know that yes, a request comes from PC0. So ARP reply is unicast. So the switch does not create unnecessary traffic within the uh, network. So now the message coming from PC0 and it will directly transfer to PC2, because switch is having information that PC2 is connected with the PC2 Mac is connected with which interface of this PC, which interface of the switch. Now see the blue PDO that is known as that is message. The green one was ARP. If I will click here, we can see the total protocol, how the message is being transferred from. This is the what are the header included with this IP, that IP address, destination IP address, and MAC address at switch. We can see the MAC address. If I will open the ARP uh, event list at switch 0, in case of ICMP, see we are having the MAC addresses also. We know the source MAC address, destination MAC address. So that's why our message, when we are transferring message from source to destination, then we can transfer using MAC addresses. So handling the broadcast domain may be covered in your lecture classes, that how switch handle the its domain, how to broadcast domain is handled by switch. Uh, all of you know, have you understand anything? Abhiraj,
Yes, sir.
did you get anything that how to work with Cisco packet tracer? Did you
Yes, sir.
understand anything?
Yes, sir. It
Abhishek,
was clear.
Abhishek. Anyone else want to ask anything? Maybe something are missing, that maybe few things I could not tell you, because I could not remember everything. I just know that how to pick and drop, so I know how to work with Cisco packet tracer, but I don't know how to what to tell. So if you will work with this, then you will know that how to what is the problem you are facing, how to sort it out. And for your assignment, what I'm going to tell you, that in your assignment, uh, the first question is to get acquainted with Wireshark. Wireshark means Cisco packet tracer, not Wireshark. Configure the given technology with Cisco packet tracer and verify communication among the nodes switch table. So you need to configure, do this topology using Cisco packet tracer, and then what I will suggest to you, that first design the topology using hub, and first design, then after that design the topology using switch, and then tell me that how what is the problem you are facing, what is the difference you can see, that what's going on, and what is the advantage of using switch over the hub. And there is a trick that how to configure this link. Anyone can tell me? Can we enable the communication just connecting to switch and connecting PC? Can we enable the communication? अविराज कर सकते हैं ऐसा? ये टोपोलॉजी बन सकती है सिस्को पैकेट ट्रेसर में? Am I audible, Abhiraj? Alok, can you hear me?
Yes,
Yes,
sir.
sir.
Okay, so you are just like not responding. Anyone is not responding means sometime I become confused that am I audible or not. So anyone can tell me that this topology can be made using Cisco packet tracer, or any extra thing is required in this topology.
We can make, sir.
Uh, so how will make enable the communication between the nodes from switch to switch? How will do that? See, switch broadcast the ARP packet, and it make decision based on MAC address. So if you want to send a packet from PC1 to PC4 and initially you don't know what is the MAC address, then how will send your packet from how will you enable the communication between the switches? I know you can do using one switch. So for that you need to enable the communication, and you need to assign IP address for these interfaces also. So if I will give a small like here, there is command line interface of the switch. Once I will click here, now we are in access mode of the switch. We can see the command line interface, and we can see in real life there is no GUI available for the switch. Once in the next lab, when we will configuring the router, then there will be an option for configuring using GUI and command line also. But in real routers there are no command lines. We need to everything in switch, everything we need to do using command prompt, so using CLI mode. So uh, let me take the one more switch. So what I'm going to do, I'm going to select a new architecture in which I'm going to take two switches. Taking two PC connected with this interface, and two PC connected with this. I'm choosing the wire. One is straight through cable, fast Ethernet. The simulation mode, I need to disable everything. Then straight through cable, fast Ethernet. Fast Ethernet 0 of this. See, now we are going to make connection among the switch to switch. Then in that case, we will be using crossover cable, copper crossover cable. So for this, I'm going to use this fast Ethernet 2x1 port is connected with fast Ethernet 2x1 port of switch 0 to switch 1. Now I'm going to do the same thing, that I'm going to assign IP addresses. This is 192.168.1.3. what I'm doing. I'm just selecting ARP and ICMP, and I will try to transfer some packets. See what's happening. This is ARP, ICMP. Just delete it. Right. I'm just taking a PC0 as source and PC3 as destination. Then see what happens. It will come to the PC0. Let's see. Switch will broadcast the packet. PC3 will send a reply. Now what's happening? Our message is coming to this PC, this PC, this PC, and reply. How to do with the CLI mode, I will cover in the next lecture. Like because once you will do know how to configure the router, you will be aware about that. Whenever you are want to see to check the MAC address table, just click here and go to CLI mode, and we can type here show MAC address table. Sorry. See, so what we can see in MAC address table, all the interface, the switch ports, all the PCs which is connected with this interface with the switch is having in MAC address table. So whenever you can see when you see the MAC address table, there are some TTL fields. So after that time, these MAC address table are get deleted and get updated. Some background protocol LLDP are used to get the MAC address of local devices connected. That are some extra thing. So from for today, what you need to do, you just know how to use the Cisco packet tracer and just try to do some experiment with using switch and hub and write the difference that what you have observed the difference using switches and hub and how to write your submission that you need to save your .pkt file and whatever the topology you have designed using Cisco packet tracer, you need to save it using .pkt extension, and then a text file is attached with that. In text file, you will write the description that what you have done. Uh, some extra thing you can do that suppose this is PC0 and using the architecture you want to tell us that what are the IP address you have assigned, you just click a note. You can say that 192.168.1.2. Once you remove it, you can see that this is the IP address assigned to this PC. So you can add text. Suppose this is the PC of 192.168.1.3. So if you want to do this, then we can see without going to the configuration mode that what is the IP address you have assigned. And one more thing, how to connect, how to check the connection using command prompt. So just remove it. Ready? If I'm going to command prompt, I'm trying to ping 192.168.1.2. I'm pinging from PC1. Sorry, I'm sending the address of same. So this is the way how to start working with Cisco packet tracer. And for today, you need to do assignment based on the hub and switch. And anyone want to ask anything about Cisco packet tracer or switch and hub, or maybe something I could not tell you that want to ask anything. How what the problem you face once you start your Cisco packet tracer? Then you will able to explore everything. That what are the maybe some text are not visible to you in Cisco, that like if some network devices are there. So these are the setup routers that routers are different in a way that how many ports are there. You can select end devices. There are so many things like servers. You can also set printer, uh, dial-up connection. So many options are available in the Cisco packet tracer. So I'm going to assign you the today's assignment, and I'm giving you 2 days time for that. So first you just acquaint with the Cisco packet tracer and know how to use it. Just install it and submit your assignment. And many of you are not submitting the assignment. Many of you are missing the submission. So all of you who are not submitting on time, or they will lose marks. I must tell you, nothing will be considered in last. But you are requesting that I have forgot everything. Many of you have not submitted any of the assignment. So try to submit your assignment on time. Anyone want to ask anything? Anubhav Mishra, Anukul, Anukul Jaiswal. Okay, if you have no question, then you can leave. And once you face any problem, you can ask me anytime. Thank you.
Thank you, sir.
अभिराज,
यस सर।
कुछ समझ में आ रहा है?
यस सर, आ रहा है। एक्चुअली नेटवर्क इशू हो जा रहा है ना, तो बीच-बीच में डिस्कनेक्ट हो जाता हूँ।
मेरे एंड से?
नहीं, मेरे एंड से, मेरे एंड से। आपका सही है।
अमन, अमन सिंह। Okay, okay, Abhiraj.